Hey, it's Mr. Barr, and this is the pretest for congruent triangles. So I've got some angles here, and it's saying, hey, what angles 1 and 3 are what types of angles? Well, 1 and 3, these are vertical angles. Vertical angles. This one. 2 parallel lines are cut by a transversal. I drew a pair of parallel lines cut by a transversal. What do you know about the following angles that are formed? The alternate interiors. These are alternate interiors, and they are congruent. Corresponding angles. So maybe something like these two guys right here. Correspondings right there. The corresponding angles, well, they are congruent. See, alternate interiors are congruent. And then alternate interiors, alternate exterior angles are congruent. Everybody's congruent. They're all congruent. All right. How can I prove that these guys are congruent? Well, it looks like side, angle, side, side, angle, side, side, angle, side. How can I prove that these two guys are congruent? Well, this looks like angle, side, angle, angle, side, angle, angle, side, angle, angle, side, angle. How can I prove that these two guys are congruent? Well, this looks like side, 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 side. Ooh, check this one out. Got a little proof going on here. Let's prove that these guys are congruent. WAX. WAX is congruent to YAZ. How do I know that? Well, they're vertical angles. I'm surprised that I brought that in early in the proof, but they are vertical angles. I've got this thing about bisects. Bisects, bisects. Well, that's a given. It was given to me up here. And AX. AX is congruent to YA. How do I know? Because it's a definition of a bisector. WA is congruent to AZ. WA is congruent to AZ. Let me mark that up. How do I know? Because definition of angle bisector. So there's my drawing after it's all marked up. And I've got side, angle, side, side, angle, side, side, angle, side. Side, angle, side. So we've got vertical angles, the given XA is congruent to YA, definition of segment bisector, and SAS. All right, we've got this little proof that we're going to fill in. So PR is congruent to TR, PR is congruent to TR, that's given. PQ is congruent to ST, that's given, or PQ is congruent to ST, given. Angle P is congruent to T, P is congruent to T, because they're alternate interiors. PRQ, SRT, PRQ, TRS, same angle. They're vertical angles. And then it looks like I have angle, side angle, angle, side angle. The two triangles are congruent. This is the weird part here, though. You got to make sure you go in the right order. So QRP, QRP is congruent to STR. Good. By angle, side angle. So given. So let's see. I've got the given. Given. PQ is congruent to ST, PQ is congruent to ST, alternate interiors, vertical angles right there, and then the two triangles are congruent. And that was just like, I think, drop and drag them into place. What question was that? Okay, and now we're on to question number 8. Okay. 1 and 5 are corresponding angles. Alternate interiors. 1 and 8 are alternate interiors. Alternate exteriors. 5 and 8 are verticals, and 4 and 5 are alternate interiors. right? 1 and 5 are correspondings, right? 1 and 5. Those are the correspondings. 1 and 8, I'm not going to mark those. 5 and 8. 5 and 8 are verticals. 4 and 5. 4 and 5 are alternate interiors. All right, and then I think we get another proof here. Prove that this is congruent to that. So I was given that AD is a perpendicular bisector, so that means that is a right angle, and those guys are going to be equal. So how did I do my proof here? So AD is a perpendicular bisector, that's a given. BD is congruent to DC because it's a bisector, it cuts it in half. These are both 90. How do I know that? Because they are a perpendicular bisector. The two right angles are congruent. How do I know that? Because all right angles are congruent. That center guy right here is congruent to itself. How do I know that? Because it's reflexive. Then I know the two triangles are side, angle, side, side, angle, side. So side, angle, side. And then all the parts are congruent because of CPCTC. And that is the video. Thank you for watching.